I'd like to welcome everyone to this executive briefing around workplace safety and AI. And on the webinar, we have Michael Liou from Chooch AI, Sean Petterson from StrongArm Technologies, and Keith Robinson from Adlink. And the webinar is going to run about half an hour, and then we'll be taking questions. Please enter your questions in the chat window. It's right here, and I'll watch this, and I think everyone can see it. You guys can all see the questions, I think, and then we'll start fielding questions and having a discussion afterwards. Super interesting topic, and I'm going to hand it over to you, Michael. Please go ahead and start.
All right, terrific. Thank you, Jeffrey. And it's great to be here with my colleagues, Keith and Sean. And what we'd like to do in the next 30 minutes is talk about industrial safety, or EHS, environmental health and safety. So I'm going to start off here by sharing screen. So Chooch AI, for those who don't know us, is a visual artificial intelligence company based in Silicon Valley. And we've developed cutting-edge technology that detects objects, images, faces, actions, and even temporal conditions. We can generate predictions both in the cloud and in the edge. And we're a horizontal ready now platform, meaning that we're somewhat industry agnostic. And to date, we've developed solutions in areas like industrial safety, which we're discussing today, infrastructure monitoring, safety and security, healthcare. We've done some stuff in geospatial as well as in the retail space. Now, the power behind the platform is derived from integrating dozens and dozens of steps across 3 key AI disciplines in the visual AI space. One is data set generation, where the team has built automated tools such as machine labeling, video annotation, and even uses data augmentation to actually take data and rapidly annotate it. And where these tools help our annotators generate over 20,000 images per day. The second discipline is the meat of it, the model training and development. And the team has built an internal no-code platform that will automatically select a deep learning framework or frameworks, the epochs, layers, thresholds, and do validation and testing, and often can generate, with these data sets, base models in a day. So not weeks, not months, but very, very rapid iterations. And then lastly, the cloud and edge inferencing, where we're able to generate fast and accurate predictions. We can run multiple models simultaneously. We can generate calls to action as well as help share that data. And then we also have deployed out to the edge as well too, via a video camera and obviously GPUs. Edge AI is very, very topical right now. We're seeing a tremendous amount of demand from our partners, OEMs, system integrators, chip manufacturers, software developers. And obviously with the advent of lightweight and high compute power developed by NVIDIA and their line of GPUs, we're able to put these very, very small devices on premise and co-located with cameras, and essentially turning dumb cameras into smart ones. We also have the ability to generate what we call very fast edge inferencing, meaning that we're able to generate predictions often under 20 milliseconds upon detection. As many of you know, edge confers a lot of advantages compared to cloud computing, which obviously is very, very scalable. One is that if you need to stream 24/7 mission critical video to the cloud, that can get very, very expensive. If you're sharing the occasional 10-second clip or image, no big deal. But in critical situations where you're trying to detect fire, or you're trying to ensure that people wearing the right safety gear to prevent accidents, this is quite critical. We also need edge computing in environments where the network might not be very reliable, or the throughput or bandwidth may not be that high. And in some instances, like oil fields, where there is no cell service or Wi-Fi, we're in comm-denied environments. And therefore, we have this need for additional edge computing. And then lastly, when you do move models from the cloud to smaller devices, there is a small degree of model optimization that also occurs, especially if you're running multiple models. And the team here has created an optimization technique that basically allows us to do this, allows us to deploy multiple models on edge devices without sacrificing accuracy, without sacrificing speed. By way of example, I think for the AGX GPU that NVIDIA makes, we're able to handle about 5 models per stream and about 5 streams per device. All this can be handled and managed on the Chooch AI dashboard. This helps provision and allocate resources where you can manage all your data sets, all your models, either customized or pre-trained. We have the ability to export, register all the GPUs on site, these near edge devices, register cameras to each of those GPUs, and then select multiple models, all deployed from this dashboard. Once inferences are generated, we can generate a call to action via text or email, and of course, also either save that metadata or the client can save it in their cloud or on-premise for additional analysis. And then lastly, we have the ability to also update these edge models automatically. So on industrial safety, it goes without saying that unfortunately, there are still way too many accidents that happen out there. 2018, about 2.5 million people sustained workplace injuries and had to go to the ER. Almost 250,000 people had to miss work due to injuries just from contact with objects and equipment. And 3 of the most common workplace injuries that require ER treatment have to do with being struck by an object or equipment, overexertion, like pulling your back out as an example, and slips and falls. And there are other things we should be doing better in this field, right? There's a lot of different standards that were violated back in 2019. And what if we actually use AI and develop the model to ensure that these standards were adhered to, and thereby reducing risk, reducing injury, reducing lawsuits, maintaining the productivity. And all this actually has impact on the bottom line, which my colleague Sean Peterson will get to in a minute. So we have built a number of different pre-trained models here at Chooch AI. One is an industrial PPE package that enables models to detect hard hats, safety vests, gloves, goggles. Obviously, if we can ensure that people are complying and wearing the appropriate safety gear, we could certainly lower the risk of getting struck by a moving object, reduce head injury, as well as reducing potential eye injuries as well too. We also can build models to monitor ladders, scaffolding, make sure you're wearing a correct safety harness while you're in an elevated position, warning people if they're working under suspended loads, and even ensuring that people who are working are not using their mobile phones. We've also developed models for fire detection, smoke detection, as well as fall detection. These can be applied in many different public areas, such as malls, obviously retail, warehouses, nursing homes. Interestingly, the current state of technology that detects fires and smokes requires the smoke and fire to actually get big enough. That's right, actually big enough to actually sets off the sensor up in the ceiling. And in a warehouse where you have 30 or 40 foot ceilings, that's going to be a pretty big fire before those sensors go off. So envision having cameras in the warehouse detecting things when they're actually quite small, and thereby alerting management, alerting 911, and actually extinguishing us sooner rather than later. For slip and fall, often these don't result in a lot of big deal, but what happens if you're unconscious? What happens if you yell for help but nobody's around because you're working a late shift? Or perhaps you're working and there are people around you, but they can't hear you because they're all wearing industrial earplugs. These are some of the use cases where visual AI can actually help and notify management that someone's been injured and render help, again, sooner rather than later. We're part of a larger ecosystem here. These are just some of our great partners within the visual AI space. That includes obviously Adlink and StrongArm. And with that, I'd like to hand it off to the CEO and founder of StrongArm Technology, Sean Peterson. Thank you.
Thanks, Michael. Hi, everyone. It is absolutely a pleasure to be here. My name is Sean Peterson. I am the founder and CEO of StrongArmTech. And we're an industrial safety science company. And the reason for our business is to protect those blue collar workers that we're talking of. We like to call them industrial athletes. They're the individuals that are working inside of the warehouses. They're stocking the shelves at your grocery store. They are building the cars on our roads, paving the roads, and really keeping us afloat. And what we do is we keep them proud, protected, and productive, and we help them avoid some of those injuries we just discussed. $3 trillion a year is spent, and that's just the start of the challenges. We're dealing with employee attrition. Some of our clients have 200% turnover rates, and hiring in this environment is incredibly challenging. The rising cost of work comp because of it. In addition, the new normal, COVID, the load that's put on EHS professionals is just one more thing to balance. And it's our goal to use technology to help avoid these injuries. It's because these injuries happen fast. You may be surprised, but during this chat alone, 38,000 people are going to go hurt or die just by doing their job. So they happen fast. We need to be faster. And this combination of our wearable technology with machine vision enables us to get to that point, to the point where we're finding the challenge, which is the lack of information from the most sensitive and integral part of the Industry 4.0. Right now, everything in the warehouse is connected except for the human being. So what we find is that embedding the insights based on safety, based on the health and well-being of that individual, we're now able to find what we see as the golden triangle, an inextricable link between safety, productivity, and efficiency. And we help you get to that optimized workforce using our platform. Our platform is relatively straightforward. We provide wearables that are prescribed for the type of job that individual is working. We deliver insights, haptic feedback, and alerts, and we eliminate the injury right at its cause. We then take that data and we provide it to the managers, the EHS professionals who are using that data to come up with a continuous plan for improvement. Not just managing by looking for people and coaching them in real time. We're using actual objective data to go down and actually have meaningful coaching moments. We then take that data a step further and we're driving it into operations. And what we're doing here is unifying all folks on the same front of safety. What we're doing is aligning incentives for operations, industrial athletes, and the business overall for productive use of safety score information. The type of information that we're collecting is based on where the environments we sit. But some of the most common factors that we're finding, first and foremost, are going to be ergonomic challenges. So we're going to measure all of the external movements, provide haptic feedback, and eliminate ergonomic challenges. We're also going to provide proximity information. This is great for forklift avoidance, tag in, tag out, lock in, lock out zones. And now we're providing insights for social distancing, contact tracing. We're able to do this by understanding where everyone is in proximity to each other and where you are in proximity to risk. We're also able to drive our sensors, if you can almost think of them as nodes walking around this warehouse. We're collecting environmental information, beaconing. And what we're able to do is essentially provide a spectrum of risk and where that individual is in proximity to risk. These are some of the wearables that we will provide. The one on the left is calculating heat, humidity, air quality, barometric pressure, height, all the types of insights in higher risk environments. And the one on the right is optimized for comfort, focusing primarily on ergonomic, social distancing, contact tracing, and of course, proximity detection for forklifts, and as well can be used as a beacon. This has worked across the globe. We've had 35,000 individuals on the platform who've experienced a 45% reduction in injury. That's 45% less people going home, 45% less people taking opioids, and we're driving true ROI. Our clients will see a 250% ROI in the first year, and that's just from injury savings from the use of the platform and driving data into the operations based on the well-being of these individuals. As we kind of look further, we're looking for new ways. Our insights here that if you can measure it, we can manage it. The next logical step for us is improving the insurance value chain. And we do that with data. We are bringing insurers closer to the risk spectrum. So we're giving them insights on risk selection. We're providing high levels of granularity around job type, all the way down to the SIC code. We're also helping price that risk based on how much risk is actually happening within the time frame of that person's job. We know down to the 12th of a second what kind of what their risk profile looks like, which really helps us out with claims. We're giving insight forensically. We know what happened before, during, and after that incident, allowing us to drive better alignment, and most specifically, alignment through risk engineering and risk management, providing real ROI to make decisions that not only reduce the risk profile, but increase the operational profile of the business itself. So where this has worked for us in some of these examples of taking safety data outside of just injury reduction into operational change. So in this particular operation, we were in a very high-paced warehouse operation where we found the ability for our platform to perform very well. Just the basis of the platform, reducing injuries in this warehouse by 50% year over year. But we found there's one location where we can get a little bit tighter. One area where this job function was not quite improving. Our data quickly showed us that sagittal twisting velocities, one of the ergonomic factors we collect, were just not improving. Training or some form of intervention wasn't going to change this. It needed to be infrastructural. So we recommended a conveyor belt with a 45-degree bend in it that essentially eliminated the ergonomic challenges and eliminated all of the injuries from there. Not only did it do that, but it also increased the throughput of the individuals on that line. We increased the throughput so much so that we actually eliminated an entire day of overage hours. They were paying time and a half for that 6-day work week. We brought them back down to 5 days. The system works because it keeps people aligned. It allows operations to make ROI-driven decisions based on safety savings, and it creates that win-win-win we were discussing with data. In another operation that we found, this is one of our power users, where they took our data and actually informed operations based on workflow. We're able to assess back down to the second what individuals' work profiles were and change their shifts midday. And by dynamically changing their shift structure based on their physiology, based on their risk, we not only saw a severe reduction in injuries, but we actually saw an increase in productivity and throughput. So as what I'd like to leave you here with today is, again, expanding the idea of what we can measure, what we can assess, and taking these insights from further just into safety, into operations. And the more we can measure, the more we can manage and improve the overall risk profile of a business. Hand it off to you, Keith.
Thank you very much for that, Sean. As both Michael and Sean have said, is that the important factor here is about gathering this data at the edge, and how do we do that? So first of all, I'd like to introduce a little bit to Adlink in case anybody's not aware of us. We've actually celebrated 25 years of developing and designing embedded edge computing technology last year. So our solutions are actually pervasive across everything, from the moment the person gets up in the morning to when they go back to bed at night. We have systems involved in transportation, monitoring transportation, autonomous vehicles, all the way through into smart city applications of monitoring and evaluating that. Once they arrive at the factory, we have systems and solutions involved in smart factories, robotics, all the way through again into machine healthcare, and obviously worker safety. So we even touch them in the healthcare environment, where our systems are used in surgeries and other areas to help improve and enable the emergency health services to provide a better service. You can't even make a phone call actually without some of our 5G technology being involved in a network. So, and once you get to the point of wanting to relax, we have systems involved in infotainment as well. So truly our solutions and our hardware and software is based across everything in a working day. To achieve this, we're very much a technology-led organization. About 1,900 employees, 30% of them are actually in R&D, developing new products, new solutions, and requiring us to work with a number of major partners such as NVIDIA and Intel, and obviously companies like Chooch to supply the end solutions. Part of the business around Edge is ensuring that we have the right open systems to enable all of these different technologies to talk to each other. So again, we're very heavily involved in a lot of open systems technologies, such as a ROS, robotic operating systems, where we're not just members, but we're also providing technology and specification information. Adlink, as a solution set, we enable the smarter applications. To Michael's point earlier on, is that you need more computing power at the edge. Transmitting large amounts of video data back up into the cloud, you have significant cost impacts. These systems are mission critical, so they require that connectivity. And they're also, as Michael quite rightly said, is we can have them on all platforms, we can have them in different areas. So there's an entire requirement around having that compute power based at the edge and at the actual place of operation. So we have a range of hardware that enables us to control that, to enable gateways, and to provide the base hardware to enable those software solutions to be carried out. Across that, we have a range of platforms of software, and today we're talking specifically around the AI Vision Link, but then we have another range of software which enables us to control robotics, auto-wear, and other edge platform technologies. How do our solutions go together? One of the things today is, as Sean was mentioning, is that the need to gather more data and more information at the edge is becoming more prevalent. This requires more and more connectivity to different sensors, different touch points, vision solutions, and even in the case of some of our examples, enabling us to talk to different systems to shut them down or highlight a risk of somebody working in a particular area. This requires us to be adaptable and also for the solutions to be able to be configured. So the way we work our systems is using a piece of edge software that we call the Adlink data river, which enables us to match and connect not just the sensors, but also connectors to the actual different interface pieces of software. One of the things alongside this is that, as Michael said, they are building the inference training for these different solutions. Part of this software also enables them to modify, change, and basically scale up and down and vertically and horizontally without having to go back and redevelop. This gives the adaptability to enable us to provide the data sets for Sean and his team to look at and evangelize. This also requires a suite of hardware. So we have a range of embedded boards and other technologies that allowed us to connect to virtually any sensor. We have a range of technologies to enable us to do the vision capture. And also importantly, we have a range of high-powered units that enable us to have the compute power at the edge technology. And it's not just about having the compute power, but in the case of oil and gas and other areas, these technologies also have to be extremely industrialized, being able to work at environments of -40 to +70 in high vibration areas as well. So there's a practicality area as well of making sure and envisaging that where this compute power is needed, that we have the capability for those systems to be working reliably and continuously. I mentioned before that for us, it's extremely important that we work with a number of other organizations. So like Jeff in his organization and Mike, that we work with a number of open system suppliers and other software suppliers that enable us to be able to talk to these multiple different systems, provide the information which is coming back into to enable those analytics to be configured, and the information back to the user, and as Sean quite rightly said, enable them to make decisions to assist in ensuring that people don't get injured in the first place. As I say, we are pervasive across a number of different areas. We're involved in solutions, everything from counting chocolate chip cookies as they come off the end of a production line and ensuring that they go into the right box, onto the right pallet, and out to the right person to be delivered. From that all the way through to railway systems and a whole multitude of areas, and even involved in battlefield scenarios. It's always interesting to me to see that the same technology is being used to check chocolate chip cookies and to be used in a battlefield. However, in terms of the worker safety environment, and this is a very important part for us, is that it's not just about worker safety, but you can generate efficiencies, as Sean mentioned as well, and improve the actual operation, which also partly also increases the safety of the workers. So I just wanted to give a couple of examples of where we put systems in place. So one of the major areas, as we all know, is about increasing security and efficiency. So not just about looking at, as we've got here, about making sure biometrically that that person should be going through that for maybe an airport or a railway station. But if you look at a warehouse, part of the solution in terms of increasing worker safety is making sure that that person is not in an area they're not supposed to be. So using this technology rather than actually just waiting for that person to have an accident, is proactive. The system could be proactive in terms of notifying and letting people know that they're in the wrong location. So Railways are becoming more and more of an important area. They have to be safer, they have to be smarter, and they have to be more reliable. So again, we have application systems where we're looking at how people board trains, unboard trains, ensuring that that's done in a safe manner, ensuring that trains do not move, but also looking at using the technology as well in monitoring how the actual railway operates, making sure that everything is in place, making sure that everything is actually correct and ready to operate. It's not just about people. When we're tracking and when we're looking at things, it's not always about, is that person in the wrong place? Is that person going in the wrong direction? Has he got a hard hat on? Other areas as well as, are the actual objects in the wrong place? So an example of this is where we're using artificial vision and artificial intelligence to actually monitor what they call FOD, foreign object debris, on runways. This is very important. Normally it's carried out by a guy driving up and down in a lorry at different times. We can actually monitor that and impart the information to say that that debris is on the runway. As I'm sure you can imagine, the risk of aircraft taking off with that debris being on the runway is very high, and it's a very, very critical situation. So again, not only are we actually making the system more efficient, but we're also making the safety higher and improving on the current situation that's there. And I think this is the important thing. When we look at this edge technology, it's not just about how we can provide more compute power, how it's efficient, but 90% of what you look at is also generating a safer working environment for the staff, to Sean's comment, the number of injuries, the number of accidents that go on, but being preemptive in terms of how that operates. So monitoring to say that within a warehouse, for example, that in the last 4 days, 5 people have walked within a foot of a fault truck, is much better to know that and change the process to stop that happening in the first place. Until, as typically what happens now, you have to wait until the accident happens and then it's reviewed. That's a little bit late in that situation. And it's exactly the same in the case of the runway example. If you wait until after an accident with an aircraft, you've got a major disaster on your hand. So it's about being preemptive and starting to pull back that information and data. From Adlink's point of view, what we are here to do is to provide that compute power, to provide that technology, and provide that data river software capability so that the data can be aggregated and sent back for the analytics and the information. I hope that's given you all a few ideas and hopefully opened up quite a few suggestions and thoughts about questions in some of the areas where this technology can be used. So at this point, I'll hand back to Jeffrey. Thank you.
Great presentation, Keith. Thanks, Sean. Thanks, Michael. So I'm gonna look through these questions. The first one, I think that's that we can ask is, my chat window just disappeared for a moment. Let me go back to it. I'm going to post this in chat so you can all see it. The question is, collectively, how do you see these technologies working together in one workplace environment? And what's a real world example of how that can work? Any of you can answer that, start off, and then you can pass it on to the next person. How do we see these technologies working together? And if you have real world examples to make it more real for people, that'd be great.
Maybe I can kick that off, and I'll speak a little bit on behalf of Sean, since we are collaborating as partners right now, and I'll mention how we obviously need industrialized hardware in some of these environments. But as Sean aptly pointed out, he focused pretty much on sensor technology and collected millions of man hours of data, ensuring worker safety. We are actually looking to combine the technologies of both sensor-based and visual artificial intelligence together in some of these environments, and taking advantage of both worlds in order to ensure that people are complying with the various different standards or so. Sean, you want to touch a little bit more upon how we're thinking about setting up some of these arrangements for some of the more complex situations?
Yeah, absolutely. So, trends in the world right now is we're seeing EHS be automated, right? We're seeing things that need to be automated just for the case of data needs to be more proactive, but also just with the advent of COVID, it's challenging to have in-person meetings. So we look to that. We look for things to start when we enter our client sites. The easiest, and then we grow. So the first way is compliance. How can we ensure people are wearing face masks in this new normal? How can we ensure that we have hard hats, we have safety vests when we're at a distance? We're able to provide those alerts based on compliance and actually not deny access to sites without compliance right at the start of our site. So we're able to do that through our smart dock, assess what the individual is wearing, and not allow them to check out a sensor. Once we adhere compliance, we're out on the shop floor. Now it's about a dynamic environment. And how do we catch all of these injuries that happen? Injuries happen fast, right? How do we be faster? So if you think of the combination of our wearables with our Chooch AI setup, it's almost like having a little bit of a coach or even a guardian angel in the sky. It's how we look at it. So we see something that is happening and we send an alert and we avoid the incidents. One good example of that is forklift collision. So we'll have a forklift coming around a blind corner. We're able to assess that and process the alert and send it to the individual on the other side. We have redundancy because our sensors also communicate with that forklift and the beacon we have on there, and we create a full picture of risk. Then taking that a step further, if an incident does happen, we now have video footage to combine with our on-sensor body data, and we're coming up with a very quick processing solution. So if you could take that narrative, that drives further. So where cameras can assess, where we solve that value now is we can deliver the insight in real time. It's not going up to the cloud and coming down into a site where someone needs to send an alert. It's happening in real time. It's keeping the person safe and getting the action and data when they need it and recording that data to improve the workflow moving forward.
Great.
So I think the thing from my side is, as I mentioned, for me, we can monitor anything, we can tag anything, we can look at anything. However, the important thing really for us is what is that important information? What is critical to that? So I think the consortium we have here in terms of being able to apply that and use the data that's coming out and fit that together to go back and actually say, this is what we should be monitoring. This is what we should be actually looking at in this particular scenario. It's great having sensors, it's great having technology, but I think to Michael's point, when we're talking about fire alarms earlier on, you have to wait for the fire to be there before the fire alarm goes off. You're sensing, you're detecting, but it's too late. So I think the big thing for us is how we can work with the other organizations to look at that data, look at that setup, and look to see how we monitor the right things at the right times. And I think that's a good thing for all of us to put together and ultimately save more lives.
Okay, so I'm posting the next, great answers, guys. I'm posting the next sort of question that I've created from several different questions. Are all of these hardware software solutions custom designed for each application, or are they all standard offerings? So are they pre-trained, pre-packaged, or are they custom? Who wants to go first in terms of that question?
I'll start. Actually, if you kind of asked this question about 7 months ago, everything we were doing was pretty much customized for people. And life to date, I think we've built over 4,000 custom models for our clients. But as we speak to our system integrator partners, our chip partners like NVIDIA, our OEMs, we started seeing certain demand signals, right? Like consistent need for certain types of applications. And we realized that we could actually produce a fair number of models, what we call pre-trained ones, that don't require customer proprietary data. But we're able to scrape data from the web, both video and imagery, and actually train these models up. And then when actually it's deployed in the field, some minor adjustments need to be made for the type of camera, the camera angle, per se. But as a result, we decided to kind of pursue a parallel path and just roll out a number of different pre-trained models. So in addition to PPE, we can throw in obviously fire and smoke that I mentioned earlier, weapons detection, slip and fall, even puddle detection to prevent people from falling, might alert people that there's a puddle there. We can customize, ensure that people aren't too close to certain conveyor belts or saws in order to keep a certain type of distance. We've been receiving a fair number of oil rig inquiries lately. Probably one of the harsher conditions where we have operated. We've actually deployed in some desert-like conditions on oil rigs, detecting smoke, fire, flares, and leaks, as well as doing a license plate, vehicle, and face authentication from a security perspective. Yep,
and to put it into perspective between what we're able to assess with real-time wearables and what we can add to the picture here with Chooch, we essentially can assess 85% of all industrial risk. Now that is a lot of data. That is a lot of information. And it's all about how do you deliver that insight when it needs to be delivered and in a way that people can interpret it. So when we deliver our solutions, we don't deliver a solution for industrial athletes or even a solution for warehouse workers. It's specific to the job code. So we'll go down into as specific as something like 8018, which is warehouse and grocery. And we're able to come up with a specific solution for that group. We're able to deploy the right model because we know that the person stocking a shelf has a different risk profile, a different thing they need to assess than a person on a 7-story high rise. Right? So in the high rise, we're able to find the alerts like, are they wearing a false safety harness? Are they wearing the right type of PPE? Are we looking for fires? And then when we go into the warehouse, it's a different model that's inferencing and promoting the right type of alerts for things like forklift collision, ergonomic challenges, and slip, trips, and falls. So that's how we work together. We prescribe the right solution based on the injury profile that comes down to the job type and the historical data that we have to reference.
And in terms of the actual edge interface, we have our platform, our edge solution platform, which, as I mentioned before, has a data river in it. That is designed to expand and develop. So we have a data connectors for connections back to the main software solutions and an SDK that fits in that. So as we roll out, we can use that repeatedly for new applications, new environments, even adding in new connectors and new sensors, etc. Our inference engine is designed again with an SDK in it. So if Michael and the team need to make changes, they can adapt as they go through rather than redevelop from scratch. So it's not a completely custom system. And as we build out, we have more and more applets and connectors to enable us to very quickly use that in different application environments. I think you're muted.
I'll unmute myself. So I'm putting another question in chat for the panelists, and this is 3 questions kind of combined. Essentially, these questions relate to surveillance, video surveillance, and invasive observation of people, and how has this been perceived in different parts of the world, whether this is US-centric or applied globally. So essentially, how is this being received from a privacy standpoint around the world?
Sure, I'll take that one. And this is actually a great reason why we love our partnership with Chooch, and it's because of our ability to maintain anonymity. So our platform is GDPR compliant, we're ISO certified, and we're essentially able to anonymize our data and roll it up to the manager so that the individual is always protected. Machine vision and using cameras has always been a desire of ours, but always a challenge because it feels like Big Brother. But what's really unique here is that we do not have to be Big Brother. We don't have to tattle on that individual, right? We don't need to tell on them for something that's inaccurate. What we're simply doing is processing something dangerous and sending an alert directly to the individual. So we don't have to go and report something of a bad actor. And that ability to provide extra assessment, extra comfort to that individual without the necessary punitive action that may be associated with it is the reason that a hardware combination with machine vision is the win that our clients like.
Yeah, I'd just like to add that it's a question that we receive a lot. We have a number of different models, including facial. One is the deployment of various different AI models into your GPUs and cameras is totally customized by the user. So if we don't have facial model loaded in there, then we actually can't identify who you are. We may just detect the PPE equipment. We can detect whether people are working under suspended loads or the number of people working in an area where there's a high degree of forklift traffic, as an example. But it's important to note that that's a decision that is made by management. Second, one of the issues related to facial is obviously the high degree of bias, and we're quite sensitive to that. So when the team set out to build its facial model, they actually built their database from taking over 1 million faces that were culturally and ethnically diverse, and thereby reducing that bias down or increasing the accuracy up to 99.7%. Separate topic, of course, and privacy is a whole separate topic. I think people do have greater concerns in public spaces where there are security cameras and the potential to recognize folks. But outside of the China, UK is pretty wired up. The United States is actually getting there, and so usually when you enter even a public space, you'll usually see a sign that says, this premise is monitored by video security. What really is changing here is that potentially, if you decide to implement facial identification, you're replacing people who want watching the monitors, with software.
Yeah, I mean, I'm living in a country which has more CCTV cameras per capita than anywhere else in the world. I suppose it's slightly less of an obstacle for me. I think the other thing as well is that we're actually carrying out the inference engines, etc., at the edge, as we talked about. So again, we're not streaming back loads of video data that's being stored and maintained. All we're passing back is the information which is contextual around the data we're gathering. And I think that's another thing which alleviates some of the concerns in this area, that there isn't multiple amounts of data being sent all over the cloud and in the other areas. And I think for a number of people, that seems to be something which is important to them, is knowing who, what, and when are actually maintaining and holding those data items.
Okay, that's great. So here, these are really great answers, and I really appreciate the questions that are coming. So here's a couple of other questions that are sort of around the same topic about how do these platforms work together? Does the Edge AI run on dedicated hardware, Chooch hardware, or does it run on different products? And also, how do the StrongArm products communicate with Bluetooth or cellular, et cetera? And where will the data eventually be analyzed or stored? How will the data be exported? So this is really a question of how these platforms work together, how they communicate, and then where does the data go?
I'll start off because it's the shortest answer, and that is we have great OEM relationships with people like Adlink and others, and we are not in the hardware business. We're also not in the hardware installation, camera installation business, and we're not really in the OEM system integration. We're a software company. And so we rely upon these partners to help us, implement a solution together. But essentially, we are optimized right now for NVIDIA GPUs across their entire line, from the small Justin line up to server, and any OEM that currently uses the NVIDIA GPUs we can definitely run our models on, both on the edge and near edge.
And our deployment process is very straightforward. So we'll deploy our smart dock. That is the interface that the end users will see, and that's the only interface that they'll have to interact with. Managers will get downloads of their safety and their information reports through our platform, and we charge a simple SaaS fee. That SaaS fee changes as we develop more models and as we grow. It starts and it's very buildable based on our risk profile. What we like to do is provide a plan of continuous improvement for our teams. And as we look for new areas to improve, we'll work with partners like Adlink to help us implement new infrastructure, to help understand each new incidents, train new models, learn about new job types, and grow that plan of continuous improvement with the life of the organization.
Yes, so from our side, as Michael said, that the software sits on our technology. We have Petterson platform devices and other various items that depend on the requirement. So the actual software is sitting on our hardware at the edge in that particular circumstance, and the software interacts in that vein. So it's a really homologous edge solution that we're providing here in terms of data connectivity.
Great. So here's another, here's a question related, it's sort of a business question. What are the biggest obstacles to making a sale? And what are the top three reasons the solution is superior to competition? Who is the competition for this? So, what are the obstacles and who are we competing with? What are the compelling reasons why StrongArm, Adlink, Chooch? It's a great question.
So, biggest obstacles for us in the sale is finding the injury profile to start with and the challenge to start with, and then helping that client see the pathway. The wearables industry, frankly, we don't have a lot of competition that's combining both of these functions, but we do have a lot of competition in very specific wearables for specific types of injuries you're trying to solve for in specific industries. So in construction, you're working on things like vibration, and then you'll work on ergonomics, then you work on fault safety, and then you'll work on, building inspection. And the IoT groups that are in charge of those are very disparate, and you find it's very challenging to bring all those things into one pane. What we're hoping to do is help provide a single pane of glass with one data set that can unify all fronts and build off of that. Our safety score is based on the time series database. We have over 25 million hours tied down to the SIG code. That enables us to start in a profile that everyone understands. Everyone understands ergonomic injuries, and we can build upon that. We can build upon their baseline for the safety score, and that's how we grow moving forward. So our barriers become, from there, educating that workforce and educating the groups so that we know where we can attack. It's surprising to learn that a lot of the industries we're in, they don't necessarily understand their risk profile. So for us, it's a matter of showing them that you need to measure it. And when you can measure that, you can put a delta to that ROI. And then from there, that's our budget to work for on innovation. And that really has been our entire move forward. Now, as we partner with Chooch, that exercise starts to condense because we're assessing more of what's inside of that risk profile. And we're providing a bigger web for new clients to enter and help them understand what connected safety means. It's not just a widget anymore, right? This is wearables are a piece of Industry 4.0 now, but how do you fold this into the greater operational bend? And that's what we're doing here. And that is hands down, I think, our biggest competitive advantage, outside of the fact that we can go to enterprise scale. We can scale to tens and hundreds of thousands of users, which is a whole nother challenge when you talk about data privacy and security. And that is something that we've built here in a very robust platform.
Following up on Sean's comments, I mean, I mentioned earlier, we are a horizontal AI platform. So there are plenty of competitors out there. Often they focus on one particular solution or one particular vertical, developing great solutions. But one of the advantages that our platform offers is this kind of a horizontal industry agnostic approach. And so we can solve not only today's problems, but tomorrow's problems. And as you start adopting more AI into your corporate operations and undergoing digital transformation, you still have a key player that can deliver additional solutions. Ultimately, in talking to some of the OEMs and SIs out there, people don't want to have 7 or 8 or 12 different providers doing different things. It's much more convenient and elegant to have one that has a uniform interface. Anytime a prediction is generated, we generate a JSON file that has links to the JPEGs, as well as the class title, the inferences, the thresholds, as well as the XY min-max of each of the objects that are detected. So it's very, very uniform. And lastly, a lot of AI companies, despite developing some really great product, it does take time. It takes time to code that. And often it takes 3 months, 6 months to get something working, up and running. And we often can do that within a day. So that's some of our competitive advantages here at Chooch AI.
From our technology point of view, there are other companies out there that make similar technology. I think where we're unique in terms of this environment is that we not only provide the embedded PC, we employ the Jetson technology, but we also provide the middleware platform and the application capability. So from that perspective, it's unique in terms of being able to provide the complete data set across the board on that side. I wanted to pick up on the comment about what is the biggest competition. I think Sean actually mentioned, for me, what I think is one of the biggest competition is actually organizations realizing the importance of doing the risk assessment and the actual risk verification behind it. When we're involved in this, and when I've been involved in this, that's the biggest eye-opener for most of the organizations that I go into, for them to see initially that there is this risk assessment, that there is this requirement behind it. So for me, the biggest sales stop is actually the customer not realizing that he needs it in the first place and what benefit it can be.
That's great. There's a number of questions around challenges. There's a question about what's the most challenging environment for doing these sorts of deployments. There was another question about obstacles and how, physical obstacles when trying to detect workplace safety. They're pretty related. And then there was a third question around foreign object debris. How real time is that? I think these are somewhat related. So challenging environments, how real time is this? And what do we do about obstacles? So obstacles in the environment. I could imagine something being in the way of a camera. And I think, go ahead, Michael, if you want to. From my point of view, that's about having multiple cameras and multiple sensors and backup systems to avoid having the obstacle be an issue. But how does everyone feel about difficult situations? Do you have examples of?
Jeff, I think you touched upon it, right? I mean, we haven't developed the AI and camera to look around corners quite yet.
Problems we've overcome with these.
Jeff's going down.
Can you guys hear me?
I can, yes, go ahead.
Yeah, hey, this is Michael Liou. So just to repeat the question, like how do we deal with obstacles or where views might be obstructed? And I was just kind of jokingly saying we haven't developed the AI to look around corners quite yet, but I think Jeff did touch upon having more cameras in key locations is certainly important. I think having a complementary sensor technology obviously can complement that ability. And lastly, there are cameras that are mounted at higher angles, 7 feet, 8 feet, and Axis, one of the world's largest camera manufacturers, actually has ceiling mounted cameras. So I think between camera placement, being thoughtful about what you're looking for, coupled with some of the different types of camera manufacturers, we can probably solve most of those type of challenges. I'm sure Sean could talk more about the sensor approach that can complement our visual AI approach.
Yeah, so I think first and foremost, where cameras can't measure, StrongArm is constantly collecting a stream of data on a time series database. So we connect the dots with that by being retroactive. As we look towards the challenges with developing infrastructure, we have to convince clients to put in new infrastructure, right? But we do that by pointing to an ROI. So we'll point to that ROI on a safety savings basis and we grow. Now, as far as most challenging environments, it's about the dynamics, right? When we talk about beaconing and tagging and looking for other forms of risk outside of the individual, it's very easy for us to put a sensor on a bulldozer or a fork truck, right? Where that is really challenging is now in these more dynamic environments. So our most difficult environment we were ever in was similarly oil. It was in a pipeline dig. So these folks were down, 20, 15, between 10 and 15 feet in a giant hole where they're digging a pipeline, right? And we're measuring their ergonomic functions, we're measuring gas exposure, we're measuring, heat and humidity while we're down there. But the biggest challenge, quite frankly, was actually crushing injuries. And we can't put a beacon on a pipe, especially a beacon on a pipe that was just put down there 15 minutes ago in the rain and the mud. So if we're able to stand up solutions where we can dynamically understand this changing environment, i.e. with Chooch, that enables us to adapt to these dynamic environments and send the alerts. And that's where this infrastructure comes back down to speed, the ability to train faster, learn about the environment quicker, and prioritize alerts based on the environment and not just, a carte blanche type solution. We're tailoring it based on the dynamics. And that's the difference between a pure hardware solution and a machine vision and hardware solution.
It's a little bit difficult for me to add to those answers. I thought they covered pretty much everything. I think the only thing for me to add from that side is that, again, the technology we're adopting here is industrial technology as well. Because it's not just about whether the camera can see around the corner, it's whether the actual technology can be used in some of the harsh and varied environments we're talking about. So another key in terms of making sure these systems are operational is ensuring that they're vibration tested, they have capabilities working across large operating temperatures. And that also enables you to, as I think Sean was saying before, when you're looking at putting in the camera technology, etc., to ensuring that the rest of the system can fit in the right location at the right place to give you that adaptability from the initial fitment and installation. And then obviously, with as Sean's commented before, taking that data and being able to be dynamic in terms of how you adapt manages around most of those issues.
If I could add, in addition to the oil rig example, which we think is a harsh environment, we have gotten a number of inquiries from construction companies and home builders. And these obviously will be more harsh conditions as you've got a lot of heavy machinery and dirt and debris kind of lying all over the place. And so we've toyed with the idea of creating like a portable server that we take from site to site, and during different phases of construction, implementing different types of models. to ensure that people are complying. Like for instance, wearing the right PPE gear, making sure people are wearing the right vest for a certain type of function, not using your cell phone if you're near an earth mover, right? And then when the foundation gets laid, a whole other set of models, and then as each floor gets constructed, and then putting these cameras and portable servers on these floors as masonry occurs and tiling occurs and other different job functions. Obviously, all of these functions have a fair amount of debris, dirt, and it's not your typical 35-degree or 40-degree server room, for sure.
Okay, well, we're almost at the top of the hour. This has been a great discussion. Do we have time for one more question? It's about 5 minutes before the hour. Yeah?
Sure.
Okay, so there's a very specific question about a specific industry within the growth. I'll post the question to the analyst, but I'll read it to the group. Within the grocery market, there's a clear demand to move smart AI camera technology within stores and distribution centers. And outside of the health and safety perks, would this technology offer elements such as age verification, empty shelf restocking alerts, item recognition for theft, Q alerts, customer emotions, inclusion of emergency services for medical issues, fires, robbery? It's a general question about what can we do for retail. So
maybe I could pick up on a couple of comments, and that's okay. Interestingly, we've already done applications where we're actually using it for the Vision AI technology for pricing food in the cafeteria, for example. So you put your food on the plate, it goes through, it detects it and says, you've got this amount of potato, this amount of Brussels, therefore we're charging that amount of money. So in answer to that, it is possible to detect and look at that, so from the aging and the other points of view. The retail sector, I think, is probably going to be an area of never-ending possibilities, from shrinkage, looking at shrinkage, coming back to the COVID requirements, self-checkout systems, things like this, which have become very popular over in Europe. Again, there's an opportunity there to move forward in terms of automatic detection. So rather than having people going into confined areas to do their self-checkout, etc., again, using this technology to do that as they walk through is more than capable. And I'm sure this is something as we come back into, and particularly the retail industry in general, not just the grocery, but the fashion industry, where they can be detecting people picking up, for instance, items of clothing and automatically making suggestions on video walls, etc. of you now have picked up this jumper, have you thought about this pair of trousers that match with it? And again, the number of examples are countless, and I think that's a big area for being looked at in the long term. So there's so many opportunities here. Again, in terms of DCs in particular, where you're looking at making sure there's verification in terms of what's going out the door. Mentioned before about pallets, etc. There's a whole area there of new technology which is non-invasive and enables you to do that. I'm aware of the time, so I'll stop and let my colleagues have the last couple of minutes to comments. Thank you.
I would say the answer is yes to all of them. We have our series of pre-trained models. We actually have a demographics model that will determine gender and age and sentiment. We'll estimate that for you. We've received inquiries on queue analysis and how can we open and close different queues based upon loads of groceries within shopping carts, based upon is a cashier typically slow, medium, or fast, coupled with how many lanes are open. But all this is doable. Planogram analysis, I think, is fairly straightforward. We've got inquiries along that as well, too. So the answer is yes. Any type of human physical task of analysis inspection, which can be taught, can be certainly replicated within our models as well, via models as well.
Well, I think this has been a great discussion, everyone. I want to thank the panelists, Seth, Michael, and Keith. Sorry, Sean, my bad. It's been a great discussion. I want to thank all the audience for attending. We had about 80 people on the call, and that's fantastic. So thanks everyone for attending. If you want to follow up with questions after the webinar, we are completely available. Please contact us at StrongArmTech, at Adlink, or at Chooch AI, and we'll get right back to you. We'll be sharing this on our blog and via email. once the recording is live. All right. So thanks, everyone.
Thank you very much. Jeff,
Thank
thank
you.
you for organising it. Thank you.
Yep. Bye-bye.